this computer. All right, so this week, the topic of this week is basically loops. So, last week we talked about branches, right? So I hope that, branching is a pretty straightforward topic. If you have any decision point at your programming code, and then you want to do different things depends on the conditions, then you're going to have a branch, right? Loop is very similar to branch, except it will just making the decision over and over and over again until some condition is met or not, and then it will get out of the loop. So branching, for example, if you are in a game, right? You are in the forest and you constantly make a decision, you want to go left or right. If you write all this code in terms of the if-else branch, you will have some infinite loops, I'm sorry, I'm using the word loop, infinite nested if-else condition, right? Every time you're going to the branch, you are constantly checking if the user want to go to left or right. Well, this is obviously a very tedious architecture, and to write the code this way is really not efficient, right? So naturally, any computer language will implement this kind of structure where you can just have a keyword, like for example here, you can constantly check if you want to exit to one direction versus another, and if this condition is correct, you will always execute this code, and then it will go back and constantly check that until this condition is not met, and then you will jump out of these branches or blocks and then continue with something else. Okay. This week we also want you to do something about the flow chart and pseudocode, right? And so for the loops, I think let me see if I have a flow chart. Yeah, here you go. So basically, the flow chart for loops looks like this, right? So you have some normal code, set up the condition and environment, and then you go to some test, right? And if the test is false, then if the test is true, you go into the loop body and just do whatever inside that block. And then once you've done this body, you go back and check the condition again until this condition is met. Then you go to another direction and continue your code. Is that clear? I mean, this diagram hopefully can help explain a lot about the concept of loop, right? Instead of doing constant like if else all over the place, you have a loop to represent, going back to the beginning and check. So you can do this thing again and again and again. The main, way to do loops, there's two different loops in Python. One is using the while keyword, right? So while means basically it's constant checking if condition is true. Then you go to execute the loop until the condition is false. So while loop is a very common structure when you're playing a game, right? So you have a game loop and you constantly check the condition if the gamer or player has win the game or not. If not, it continues the game until you lose, right? Either you're winning or losing, and then you are getting out of the loop. So that's very typical. So the common construct of while loop is some condition, it's Boolean variables, and then you're doing some expression. Now, of course, just like if else, you need a colon at the end of the first statement, and then you have some indentation. And once you're out of the indentation, you are out of the loop. Okay. All right. So hope that's so yeah. And one typical thing about using while loop, this is a technique when you're checking the user input. For example, here you're asking user to give you a input so you can continue your game, right? And you're checking if the input is the word right. If it is, then you just constantly asking, you want to go left or right, right? This is like a gaming condition we set up. And then If the user put anything other than right, then you are out of the game loop and you print that you got all the lost first. So that's a, kind of way to program it. Now, the other way I want to think about is, let's see, you use that to sanitize your user input, right? You are expecting user to give you, say, an integer, and if your input is not integer, you can say, hey, give me an integer and continue until user give you a correct format. Then you can continue with that. So you can use a while loop to keep checking the user input, and it's a very common practice. There's some examples on a while loop, right? So one caveat of using while loop is if you're not careful, you will get into an infinite loop condition, which is bad, right? The program will never stop. So you want to change the condition after each iteration, or maybe a couple iterations. Eventually, you'll get out of the loop, right? So here, for example, if you forget to increment this I, right? I equal to I plus 1, then you will constantly print the number I infinitely. That's not good. However, if you put I equal to 0 inside the loop, that's one more common mistake. Then what happens? Right? Every time you go through the loop, you are clearing the I into say if you put I equal to 0 here, what happened? Every time you go to a loop, I is less than 5, okay, I equals 0, and you add I is 1, and I is less than 5, I equals 0. So if I is changing between 0 and 1, 0 and 1, they will never be greater than or equal to 5. So this while loop will never end. So don't do that, right? This is one common mistakes. Less than 5, right? So I don't need this. This is a mistake, okay? Now there's another kind of loop like I alluded to, is a for loop. For loop is mostly used when you know number of loops in advance, right? If you specifically know, yeah, you want to loop 100 times because you want to generate 100 numbers, then you can use a for loop. And for loop is very versatile in that in Python, this is not a so one example for the for loop is like this, right? You have a variable I. Usually we use I indicate a iterator, right? A I, and in range function, the range function will give you a number between 1 and 6, not including 6. 6 is not included, so it's 1, 2, 3, 4, 5, right? And then each time you go through loop, I will take a different values from the range. Right? In this case, it's 1, 2, 3, 4, 5. And the third argument for the range is the step function. Okay, let's just practice here. You guys see my screen, right? So for I in range, let's say 1 to 6, if I step to 2, okay, that means every time I skip 1, right? Skip 1 and print, maybe just a print I. Okay. All right. I'm running it. So 1, 3, 5. You can see 1, 3, 5. 6 is not included, right? So basically, range function is something like range from start to finish and step, right? So that's the construct. Starting number is included, finish number is not included, just like a string slicing. Step is your step, right? If you go to -1 step and maybe 6 to 0, what will you get? You'll get 6 all the way to 1, right? 0 is not included and it's counting backwards. Okay, so that's the range function. So that's a very basic use of the for loop. Okay, and for loop will automatically end when this I is out of range, right? When the I is 6 in this example, it's out of that range, then you just get off the loop. So that's a typical construct for the for loops. And you don't need to worry about incrementing the I manually, because in the for loop, the I will be automatically increment. So you don't need to worry about changing the I yourself. Okay. Yes. Is that clear? So go ahead.
No, it makes a lot more sense now. Except with the while loops, you don't have to do the
Yep. Exactly.
The I plus or equal
yes.
1.
In while loop, it's basically a branching with, you check it every time, right? The conditions. So then you have to be responsible for changing that condition, but even each time iterating the loop. And for for loop, because the I is automatically set up to increment, so and it's the destination already. Here, the range function is very useful, right? The range function will give you one number at a time, okay? And so it's basically a better way to give you a number sequence than as if you can iterate through some collections like list, tuple, or dictionary. So for loops is often used to iterate through a data structure or collections. For example, I'll give you a list 1, 2, 3, 4, 5, 6, right? So I can do say something like for I in I need to assign a variable name like list1, for example, right? For I in list1, okay, so I'm iterating through the list1, okay, and print I, okay. So we can compare these two. What's the difference? There's literally no difference in terms of the content, right? 1, 2, it print out 1 to 6. Of course, this time you specifically know you want to print all number in that list. That's more specific. If you use a range function, what do you write, right? You can use, say, range 1 to what?
7.
7. Great. Got it. You can omit 1 because by default, yes. So it's the same thing, right? So what's the difference? Okay, I omitted the colon, right? That's important. Okay, what's the difference than that? Well, here's the thing. You can do 1 to 100, right? 1,000. Let me see, and equal to. So I don't want to have a lot of, and then just write it. You can see I'm generating 1 to 1,000 number very quickly, right? And the good thing is it will give you one number at a time. So you don't need to worry about store like 1,000 numbers in a memory and then iterate through them. If you use them all, that's okay, right? But usually if you only use a couple hundred numbers in the beginning and you don't touch the rest of memory, this is a wasted memory. So this range is better, oftentimes better than just specifically list out the list number one by one. Is that clear? So yeah, prefer this than that, unless you have a specific list that you want to iterate through, especially for numbers. Now, of course, you have a list of strings, list of lists, then that's a different story, right? But this is one way to, same thing for tuples. Tuple is just, what's the difference between tuple and list, right? Tuple is immutable and it occupies less memory. So you can also say for this in tuple 1, right? And you can print everything in that tuple. Okay, 1, 2, 4, 2. All right. So that's that. How about dictionary? I'm actually, dict 1. Let's say 1. So key and value, right? 1 is 1, 2 is 2. And we'll talk about that a lot. I like dictionary because there's a lot of usage here. As a matter of fact, in our project, you're going to use a dictionary or dictionaries to simplify your. So we have a dictionary. How to iterate through a dictionary? For I in dict 1. So if you do I this way, you are iterating the what? The keys, right? The key and value. So you're iterating the keys of dictionary. If I print that, I will get 1, 2, 3. That's the key. Well, how about I want to print out the values? Well, there's 2 ways, right? You can do I of, well, typically, let me just say for key, right? So this is more More clear now? You need to use a sensible, meaningful variables to help you understand the code. So for key in dictionary, you can print the key, and I can print out the value. Now, what is the value? Well, it's basically the dict one of key, right? That's how you access the value. You give them a key and you get a value. You can also use get function, .get, right? Get key. Then you can get the value. So what's wrong here? Key and value. Maybe I can just make it a pair. Come on. I want to make it a pair. So I will print key, comma. Oh, I have a misspell, dict one. Yeah, okay. Key value and is that. So let me run it. Now you can see I'm cleaning out the key value pair as a tuple for my dictionary. Okay. Any question on that? This is how to iterate through the collections using for loop. Now, if you want to both the key values, you can also use this, construct dict.items. So this item function will give you both the key value at the same time, and you can just print key, comma, value. All right, and just to run it. As you can see, it's going to be 1, 1, 2, 2. Just print here. Empty print here will give you a new line, right? So that's how you iterate through the dictionaries. Okay, just keep in mind that these are the typical ways to iterate those collections. Is that clear? There's a lot of applications there.
Yeah, it's pretty clear.
Cool. So now we can use those what you learned in some application. Let's see what else is important in this chapter for the loop thing. So you know the range function. Let's see. Oh, the break statement. Okay. So sometimes in construct a problems or solving a problem in Python or other computer languages, you use some loops, but then you don't want to. So for example, you are searching for a number in a list, okay? Searching for a number in a list. You can use a different method, but typically you iterate through the list and find if the number meets a target, right? And if you already found a number, you not necessarily need to continue your search if you just found one number, right? In this case, you can end this while loop early by using a break statement. So break, basically, once you see break, it will immediately get out of the loop, okay? And it will get out of the inner loop if there is a double loop here. So the concept of nested loop is basically very natural when you're dealing with, like, for example, two-dimensional matrix, okay? So you're iterating rows. So for each row, so like, for example, 5 by 5 matrix, right? You are iterating those, let's just do an example for I in range, let's say 5 by 5, right? For now, I use a different letter to represent the inner loop, range 5, okay? And I'm gonna print print a asterisk, and I'm gonna use and equal to a empty string, right? So internally, I'm printing 1 row at a time, and then I'm printing 5 rows, and then I think this is, I'm gonna print a new line for each row, okay? So I'm printing 5 times. Let's run it. Okay, oh, there is, oh, sorry. This one should be indent for this loop. Okay, so what's the difference here? This print is in the inner loop, right? For loop here. And this print is flushed with this for statement. So the whole thing is internally a block for the outer loop. So the outer loop will print a new line. And that's what we want, like this, right? 5 by 5 matrix, 5 by 5 stars, okay? I think in one of the labs, you're asking to print a triangle. You need to think a little bit through. I think you need to vary the inner loop every time you go through each row, right? So that's a little variation of this example, but you get the idea, right? You need 2 for loops to print out the 2-dimensional thing, which is pretty natural, right? Now, what happens, like initially I made a mistake using print in this location. Well, if in this location, the print is actually what? Outside this 2 loop. So it will continue all 5 by 5, 25 stars before it print a new line. That's why if you put print statement here, it will only print in one line. There's the new line at the end, right? Once you finish all 25 stars. Does that make sense? Versus here, right? Here you print out new line per each 5 star in a row. So there's a 5 columns, right? J is a column number, I is a row number.
Can you continue doing inner loops and there be more than 2?
What do you mean by more than 2?
So if you were to do like put it indentation and then do like for n in range 5, would it?
Oh, you mean 3-dimensional, right? So
right,
you want to another, yeah, you can do 3-dimensional, yeah, for K, IJK in range 5. Now, this is getting interesting. Now, obviously, you are printing things in the 2-dimensional canvas. You cannot really print 3-dimensional thing, right? You cannot have a vertical axis or whatever. So what happens here, maybe you are checking, but maybe you can check. So I don't know. I just need to find the application here. Now, obviously, if you do this 3 nested loop, how many total stars you're gonna print? You're gonna print. It's a nested relation, right? For each outer loop, go ahead.
Is it like 125 of them?
Yeah, so it's 5 cubed, right?
Right.
So 5 times 5 times 5, exactly. So you're gonna have, so if I put it like this, I'm gonna internally it's 5, and so let's run it. Let's see what happened here. Okay, it print 125 stars. Now, of course, it's still 5 stars, 5 columns, because that's inner loop does, right? And every time you print a new line after 5 columns, right? 5 stars, and you do it 5 times and then 5. Now, of course, if I do print here, and then I do another print here. Wait, no, I don't do print here. I do print here, right? So this is like every 5. Okay, yeah. And then I do a print here. Okay, so let's see what's the difference. You see the difference now? So it's printing the 5 by 5. So the inner 2 loop J and K is printed 1 sheet, right? And the outer loop is like you are stacking those as if, imagine this is like Z direction, right? So you are printing out each sheet 5 times. That's how to go. That's like a pseudo 3-dimensional thing. Can you imagine that? So yeah, 3-dimension is totally possible. So this print is basically a new line for each row, right? And this print is a new line for each 5 rows, because this is rows. And then I is like a 3-dimensional, like So maybe I can make it more easier in mathematical term, XY coordinate, right? XY is a plane and Z is another dimension. So basically it's a different variable, but it's the same thing. So each group of 5 by 5 matrix is like a layer on top of each other. Okay, imagine that. So it's 5 layers stacking from bottom to top. Does that make sense?
Yeah, that makes sense.
Yeah, so depends on where you put the print, you are adding new line for each location. All right, so yeah, that's a nested loop. Very good question. And the while loop is the same thing. But you can use a break to get out of that if you already search for it. Like what this program does. Okay, for example, here, I will let you look at this and you can tell me. In other words, what is the printed numbers on the screen when this program finishes? Notice there's a break here, right?
Would it be 10?
Okay, why is 10? Let's take a look. So this range means you are printing out from 5, 6, 7, well, 5 to 11 and skip no, step is 2, right? So it's 5, 7, 9, 11. 11 is not included, right?
Right.
Okay,
So
doesn't
it'd be
matter.
9.
But the first number is 5, right? The first time you go to the loop, what is I? I is 5, right? You take initial value 5, okay? And then my sum originally was 0, right? So my sum plus equal to I, what does that mean?
Means you add
I to whatever initial value. Initial value is 0, right?
Oh, so you'd add 5.
Add 5 to 0, which is still 5, right?
Right.
So at the end of this statement, my sum is 5, right? Now there is a conditional statement if my sum equal 5. What does that mean? You're checking what?
If the sum is equal.
Yeah.
Is equal
is
to
that
5.
True?
It's true.
So it's true, then it will hit the brakes, right? So it will not go back and loop anymore. When you see the break, that means you really break your loop. So you're out of the loop. This is the statement out of the loop, right? So you are not no longer iterate again. So my sum stop at 5. And when you printed my sum, it's gonna be 5, right?
Right.
Okay, let's prove that. Okay, so you need to do that if my sum is a break. All right, and then finally print my sum. And let's just let me comment out this code. All right. Okay. Run. So my sum is 5. See, break basically changes the workflow inside the loop, right? Now, if I slightly change this, okay, so it's a break statement. let's just summarize when you still want to use a for loop, when you want to use a while loop. Obviously, you can do everything use a while loop, right? But you probably may not do everything use a for loop, because for loop, you need to know the number of iterations prior to doing the loop, usually, right? And it has a internal counter that keep tracking how many times you are into the loop. Now, for the while loop, when did you end the loop is sometimes is not known, right? You have to check the condition, okay? It may never end, so you have to be careful about it. You can pre-terminate this on both loops using a break statement, right? You must initialize the counter before the loop and increment or decrement inside the loop. So yeah, that's the condition you want to use. And I also told you this statement, okay? Let's see, did I talk about continue? Oh, there, let's just talk briefly, continue. So you can also use a continue statement. What continue does is basically it will skip the current run. If I can spell it right. Right, okay. So continue basically means it will skip the rest of, say, for example, if you print my sum, right? If you print this inside the loop, but I'm continuing, that means I'm not gonna skip the 5, and so let's just run it. Okay, so you can see it's printing out 12 because initially it's 5, right? But if it's 5, I'm gonna continue. That means I'm not gonna print. I'm gonna skip the rest, but I'm going back to the for loop, right? Instead of using break. Break means I'm done with the loop. I'm out of loop. This is the out loop statement, right? Let me just say outside loop. Okay, comma my son, and this is like inside loop. Okay, so yeah, let's run it. Okay, you can see first of all your inside loop, and so next time the my sum is 5 plus 2 is right, it's 12. Why is 12? That's interesting. Oh, it's add. Okay, that makes sense, right? So basically, my sum was 5, and the next number is 7. So 7 plus 5, right? Is 12. Does it make sense? So my sum, let's just print out. Let me just print out print I. Okay. So let's run it again. So you can see initially, let me just get rid of all these print statement. It's kind of annoying. Yeah, I'm gonna only print out this while. So focusing on. I'm just gonna. So focusing on this guy, right? Did I? Oh yeah, I'm just. All right. Focusing on this program. Okay. Let me run it. So it's clear now. The I initially is 5, right? And my sum is 0 plus 5 is 5, and it will print 5. And because my sum is 5, I'm not going to print this because I continue. I basically do a shortcut that continue with the next iteration. So I is becomes 7 because 5 plus 2 is 7. And my sum is 7 plus previously 5 is 12. And so I'm printing out 12. And the next time, what is number? 7 plus 2 is 9, right? 9 plus 7 sorry, 9 plus 12, not 7, because my son is 12 now. 12 plus 9 is 21, right? So 21, and it's not equal to 5. So I'm going to print out 21. So it will print out these two numbers. Only 5 is not printed out. And then finally, the number is 21. All right. So I guess there's a couple of things that you need to remember. One is this is called accumulator, right? It's just adding all the numbers all together, right? Maybe I should just change this to like 5, 7, 9. Okay, if I change this, then things may be clear, right? Because now you clearly see it will, I will take the number 5 and then 7 and then 9, right? And then I'm adding up, I'm accumulating the summation up to this number, right? It's called prefix sum. And then it will print the number I, which give you that number. Okay. I think that's break and continue. Do you understand the difference between break and continue?
Yes.
Okay, cool. One more thing about this for loop. Sometimes you want to, because this for loop is Python idiom, right? You want to get the actual number. But what if you want to get the index and the number? For example, right? If I can do string 1 is I love coding, okay? And I want to print out each letter. So I can say for letter in string 1, okay? You can print letter. Okay, so then it will print out this I love coding, right? 1 by 1. Now, if you want to also have an index, you can say I comma letter and enumerate. Enumerate is a function, take a collection. So basically enumerate on the string will give you both index of that string and the letter. So I want to print I comma letter. Okay, let me just run again. And you can see 0 is I, index 1 is empty space, 2 is L, and so on. So it gives you both the index of that string and the string itself. Is that clear? So sometimes you want both index for that string or a list or tuple, any one-dimensional collection, or even it's very similar to the the key value pair in the dictionary, right? In dictionary, you have like each item is a collection, a tuple of key and value. Here, string or list, you can think as another dictionary was key as index, right? Key is like 0, 1, 2, 3, 4, and the value is basically actual letter or whatever in that string. Sorry, the list. Okay, so it's very similar to a dictionary, except here you need to use enumerate to get the both. And in the dictionary, you just need to do items, right? Items will give you the items. All right, so, well, just do more practice and you will be able to remember these functions, items, and enumerate. I'm not expecting you to remember right now, but just so you know, there's something there. Now, keep in mind, if you want to use both, there is a function and you can perfectly, you can Google it or just refer to the Zai books and to get that exact syntax, okay? So, but just be aware this is there. I think we covered most of the things about loops and so next, I think I want to talk something about the Zybox libraries. Now, with the iteration and branching, you can do a lot of, fascinating stuff, right? A normal thing about a problem is to search some answers in some space. Say, for example, you want to find the cubic root of an integer, right? there is a common algorithm called guess and check. So you know the answer lies in a positive integer, right? Numbers greater than 0 but less than the actual number, right? Depends on, say if you want to compute the cubic root or square root of an integer, or radical of number 2, right? You know the numbers between 1 and 2. So you can just iterate through all the floating numbers between 1 and 2, which is infinite, right? But you can have a very little step, like 1.1, 1.01, 1.001, and you iterate through them and until you get a number close enough to that number. This is called a guess and check. So use just using a loop to iterate through them, and you check, if the answer is close enough. So that's a very, very fundamental thing that using a while loop you can achieve. So you can just guess and check. So it's very fast in computer, right? So let's talk about some lab problems. So you can, so let's see, first one. Let's do this password modifier. Have you seen this problem yet? This is a 4.15.
No, not yet.
Okay, so let's try it using our knowledge password. So I have copied the problem here. So what's in your mind? Because I will let you read this problem first. Do you understand the question?
Kind of. So we're going to ask the user to enter a password.
Yep, so password is equal to input, right? And you can say enter password. Okay, so now we get password, all right? Suppose we get password. Now what?
Amigo, what's this?
Go with your dad. Go with your dad.
That's okay.
So we're gonna create a
so you need to iterate through the password somehow, right? To basically create a new password according to some translation or rules. So we talk about how to iterate a string, right? So suppose password is already, let's say password is, what's the English password? My password. So to play a naive password, a user give you his password is called my password. And then you want to iterate through the passwords. You can use this idiom, right? For like car, ch in password. Okay. Now, one idiom is to want to print out. Maybe I want to, let's say, new password. Okay, new password. Initially, it's an empty string. Okay, so basically it's empty. Now I'm gonna copy the original password to the new password, but have a condition, right? So the conditions is like if the ch is in something, right? I'm just putting there. So basically I need some data structure to hold the translation. So if I saw an I, right, I want to replace with this exclamation mark. And if I have a letter A, I want to replace with at. You know what I mean? So this is like replacement rule, right? This is like almost like a lookup table, shall we say? And once you see one letter on the left, and we're going to replace the other letter on the right. This looks like what data structure to you? What data structure that looks similar to this translation from one like key to another value, right?
I don't remember what it's called. We put it in,
It begins with letter D, right? You learned the list, you learned tuple, you learned dictionary, right?
Right.
What data you're gonna use? Choose one.
Tuple.
A tuple? I guess a tuple also works. Yeah, a tuple also works because you can have a list of tuples. Are you talking about like a list of like I comma external mark, right? So if you saw the first one, you know the second one, right?
Right.
That works. Yeah, that works. You can do that, or I can do this more compact structure, which is a dictionary. So I use the first letter as a key and a second letter as my value. Can we do that?
Okay.
So that's this dictionary, right? I really like the dictionary. So let's just do that. You see what I'm doing? This is a dictionary of key and value pairs. And so lowercase m replaced with uppercase m, right? You got the idea? B is replaced with 8, right? It's all characters. And then lastly, O is what? Dot,
Period.
right?
Yeah.
Okay. So now this is dictionary, right? So basically, if now I can replace this is if CH in TR, what does that mean? So basically TR is translation dictionary. If my character is in this dictionary, means the key, I found the key, right? If the letter is within the key, I'm gonna replace, I'm gonna append that replacement word of TRCH, right? Do you understand this? So basically, I got the key, which is in the dictionary. So I'm gonna, so whether it's I, A, it doesn't matter, one of them. I'm gonna replace that letter with my value, right? So I saw A, I replaced with at. I saw B, capital B, I replaced with lowercase number 8. Does it make sense? So this line, this if statement, is to guarantee that if I hit one of these letters on the left column, okay, I can replace that with the corresponding letters, which is the value in this dictionary here. So I use that to replace my letter in the password. Okay. Now, else, okay, else. So if the key is not one of them, what we do? You have an else statement, right? If it's not within that dictionary, that means it's just something else, and we just let them pass through, right? It only replaces these keywords, but other than that, I'm gonna just add this to the password. So CH without changing. Remember, CH is the original password, each letter on the original password, right? And the new password will copy letter by letter through this for loop, right? So basically, you are printing out letter for letter, and you get this. Okay, now you're out of the for loop. Now what? Now you want to also, don't forget, by appending Q star S to the end of the input string. Okay, so I'm not gonna do that. I will let you as an exercise, but I'm gonna print out original password and also print out the replacement password. Okay, let me just run it. Actually, I have to run it here. Python password.py. There is a problem here. While, where is the while? Line 60. Oh, okay. I have well, so there's more problem here. All right, here you go. Wait, no, I have to run it here. Enter password. My password. You can see the original password is my password, and the replaced one is capital M yp@ssw.rd, right? Clear? Maybe I shall have this, so, you know. Any question on that piece of lab exercise? What's the purpose of this for loop?
I guess to change the password. Or what are we using the ch for as like?
Oh, ch is
chain?
a dummy variable. Okay.
Oh, okay.
It's a dummy variable. You can name it anything.
Okay.
It doesn't change the result. Let's do it again. My password. Ch is, oh yeah, because I have to change this to dummy. It's just a variable. Okay, that variable holds the letter for each inside the string. Does it make sense?
Yes.
My password. Okay, so it's a dummy or it's a variable. You can use anything like p. That's what I mean. What is what I do. But you know, I suggest to use a meaningful variables. Otherwise, it will be very confusing. In computer science, usually we use I and J to indicate the iterator indices when you loop through a list or strings and so on, right? The indices. But in Python, you use this to indicate the value for each letters in that string. That's why ch like is a character, or you can see car, because sometimes car is a keyword in some languages. So I use ch, or you can use c, character, or letter. Maybe that's easier.
Okay. Yeah, I understand. That's a little easier to understand for me.
Yes, that's the power of using a meaningful variable, right? So that's also a industrial practice. When you write the code, you also judge by how wise you are to choose some meaningful. And also, see, I use some comments. You need to use comments too. Okay, to the this is, say, if I were put some comment, what are you gonna add here, right? Does it make sense?
Yes.
So iterate through each character in the input string. That's this. You can also put this right on top or at the side, so you know this line is indicating that. And inside it, you are judging. You can, if you will write a comment here, what are you gonna write, right? Replace. What? Going to replace.
Letters in dictionary or in TR.
Here, this is the key. Replacing character using the key. So
okay.
replace
character
cars from the keyword dictionary, right? So basically, you're replacing characters from this dictionary. If it's within dictionary, I'm gonna replace it. Otherwise, copy the character as is, right? Without modification. Does it make sense? So you need to put some comments here to help you understand what each branching or looping does. That's a good practice. So now when you look at the code, you can just look at the comments and say, oh, that's what I'm doing. Cool?
Cool.
I hope that makes sense to you. Now, of course, you can use different structure like a dictionary, or you like to say tuples. I encourage you to use tuples as well. You can practice with all different, you can have a list of tuples, right? Like TR2, let's say you have a list of tuples. So basically it's I comma that, right? That's the first element, it's a tuple. And the second element is like A comma at. Very common, right? Now maybe I can just replace let's see, for fun, right? S, there's no S yet. Let me just add some more table, for example, S to replace with 5, maybe O, oh, there's O. Like D with, there's a D, no D. D with what? Like G maybe, okay? So TR2, so you can use that. Now I'm gonna do a second round of replacement, right? Second round of replacement, or maybe I just piggyback on this for loop, right? What are you gonna do if you pass the try? Okay, let's do an else here. How about that? Else here, okay? Letter in TR2. Well, this is interesting. I don't know. This is, see, the thing is that if you use structure like this, right, it may not be easier for you to iterate through them, okay? Because it's a list of tuples. Right? So you need some like key value. So I think a still see dictionary is better. Would you agree? Because this one, how do you iterate them? You can iterate through each element in the list, which is a tuple, right? But how you gonna know what's it corresponding to, right? So this may not be a good choice, okay?
I think the dictionary makes more sense.
Yeah, I agree. Otherwise, you have to do like, you could iterate through them and say, if the tuples 0 is S, then you do that. So yeah, let's just get rid of that, okay? I think our time is up, but maybe we should go through one more lab. I don't know, you're for it?
Yeah, that's cool.
Okay, so get interested in that. Count input lengths without spaces, periods, or commas. Give a line of text as input. Output a number. See, this is the key. A line of text. So it's your input has to be on one line. Okay. Output the number of characters, excluding spaces, period, or commas. So if this is your line, you want to count something that is the number of characters. So what we go about that? So basically, you're going to translate this input into a code, right? Python is very similar to English languages. Do you agree? So let's do that. So basically, what's the first thing you want to say? Get the first you can write a pseudocode first. Let's go ahead. Get user input, right? And you already know how to do that. Let's give them a variable, like word, okay? For letter input, and then enter your word, and then done. So you have a word, and then you want to count number of characters, right? Without the additional requirement, how do you count the number of characters in the word? Any idea? Count number of car in word, right? There's multiple ways of doing that. Okay, multiple ways to do that. Now, the most brute force way, or obvious way, if you don't know any functions given by a string, right? As a matter of fact, their string has, word has, you can use a function length, right? You can calculate the length of the word, and that's it, right? but then that doesn't cut because the space should be counted as number of characters, right? So that's probably not what you want. So maybe remember how to iterate through the string using a, because this week we're talking about loops, so you better use a loop, right? Now you can use for loop or while. What loop you want to use?
For.
Yes, for loop. So for, maybe given the name, I use a letter. Okay. Word. Does it make sense? So basically, you're iterating through the word, one letter, one character at a time, right? So now you want to count. If you want to count, you need a counter, right? 1, 2, 3, 4, 5, right? And you want to put them into a variable. So I want to use a counter, count, okay? Plus equal to 1. Does it make sense? So you are adding, but you have to initialize the count, and you have to initialize outside the loop, remember? So initially the count is 0, that there is 0 letter in the word, right? And then you just add 1 whenever you see a letter. Does it make sense? It's like,
oh, okay. So it's gonna skip the spaces.
Well, initially we haven't skipped yet. We have not skipped it. This is just a count. Let's just print as is. See, the thing, another secret about doing this kind of programming is you code a little bit and you run the test. Okay, you add some feature and you run test, and then you add more feature until you're done. Don't write everything all together and then debug yourself. That's gonna be a messy, right? Sometimes some students say, I spend 1 hour, 2 hours debugging your code. Well, if you just do some debugging every time you add a new line or two, then I think in the long run you're gonna save more time. Does it make sense?
Yes,
So,
I find myself constantly running, like every other line.
Yeah. So see, I only wrote like, I know this one is gonna work. So we have write numerous times, right? And I'm trying to test the count. I'm gonna print my count, okay? And see if that makes sense. This is simple enough, right? To test immediately. I guess I can comment out this guy. By the way, you know how to comment out code? Yeah, you can just do that. Triple quotes. That's a comment. Okay. So now I'm going to focusing on this function. So I'm going to run it. Yeah. So let's say, what's the word? Listen, Mr. Jones, calm down, comma, 29. Okay. So that's about right, right? So now I think we are almost there. So what's missing? Now, of course, comments. Okay.
Mm. Can you do like would it be like an if statement, like if
exactly
there's a space?
So you can use the if statement, like if the character is a space, if the character is a comma, if a character is a dot, right? Then you're gonna skip. So you only count if, okay, if the letter in, I'll give a tip, right? So I can have a tuple of comma, okay, dot, okay. So hopefully you recognize this pattern, comma, dot, and space. What else? Comma, dot, and space. Is that all? Spaces, periods, or commas. So this is space, periods, or comma. Okay, one character at a time. All right. So now, if the letter is one of them, do I count? I don't count, right? Let me just say I count only the number of space and that. Okay, let's just run it. I need to do that again. Okay, I don't feel like it. I'm gonna copy and paste. Okay, maybe you should skip the input part. Okay, 8. So there's 8 comma space or dot, right? And you know the total length is 29. So what do you do?
Or subtract it.
Subtract. You can subtract the size. So you can just subtract the length of the word, subtract the count. So you're counting this, right? And you use that. That's one way of doing it. If you just want to be more straightforward, right? I want to just print the count, right? The count is actually the useful characters. So I can use a inverse logic, right? I can use what? Not. Okay, there, don't put not here.
Okay.
Not is negate of the whole thing. So because letter in this statement give you a Boolean value, right? You are negating that Boolean value. So you put not here, not true. So if letter is in, that's a true statement, right? If that's true, then not true is false, right? If not true, that means the letter don't belong in those one of them that I can count. Does it make sense? So now you only count. Okay, now let's run it. This time I promise, and then you just paste. I hope it's still there. 21. You got the answer. Now the answer may not. Well, it matches, so we must be right. Does it make sense? So
yeah, that makes a lot more sense.
This is much simpler than you can do 3 if statement, right? What's the advantage of this structure? Then you do a 3 if statement. Like 3 if this is not character, if it is not dot, if this is not space. Can you tell me what's the advantage or disadvantage of using this structure?
Well, I mean, there's less coding. Yeah,
less but more importantly, it's extendable, right? If you want to add more filters, you can easily add into this list, right? If you want to say filter out asterisks or other things, you can just expand this list without do another if statement. In general, you should avoid a lot of if statement, okay? If a nested if statement, that's what I want to say. I think finally the lab for the MATLAB, I think you already did that in previous, I don't know, in chapter 1. This case, you need to use a while loop to get the user input until the user hit quit. Okay, so the 2 key things here is, first of all, how to extract elements from one line. Say like each time a user give you, like, let's say in is equal to input, right? Your input. Okay, so every time user give you input like apple 5, how do you retrieve that? Because this is one string. How do you get apple and 5 into 2 variables? You have any idea?
Like put it in a dictionary?
Well, this time you can use a tuple. Word and the count, okay, is equal to in dot split. Do you remember the split function? You can split, you can split that into a list. Actually, is that let's test it. Okay, let's test it. I'm not sure, because I know split give you a list, right? You know that. Then if that automatically convert to a let's user input. Okay, user input. Okay, let's say this one is a list. I can say tuple. I can convert it to a tuple. Can I convert it to a, yeah, I can convert a list to a tuple, no problem. And I'm gonna print word comma count. Okay, so that's for see, I'm not running the whole thing. I'm just doing one at a time, right? One function at a time. Say like apples and 5. Okay, you get apple 5, right? So you can actually assign this to that. Now, of course, you can also do just a list, right? Doesn't, you know, use a list is equal to split. So you don't need to convert the tuple. You should just use list. Then what you're gonna do is just print u list of 0, right? And u list of 1. Does it make sense? So you can print, you know, the first element in the list is the word, and the second element in the list is the number. Does it make sense?
Yeah.
Right. Apples and 5. It's the same thing. See, apples 5. So there's multiple ways to skin a cat, right? Just first of all, programming. Sometimes people say programming is data structure plus algorithms. So what data structure is like what data you're going to represent the physical world, right? In this case, a string, a list, a tuple, or dictionary, right? These are your weapons, or maybe even a list of tuples or string of, a dictionary of dictionary, or a list of list, a two-dimensional list, right? These are the weapons or data structure you now need to master, or just click that, you know, can simplify your code, help your coding easier. Now you learned the while loop, the list, the branches, and you learned how to, you know, when you iterate through them, then you're golden. You can do a lot of things already. It's very powerful, right? Simple things like that. So once you know how to access the entry of the list, and then you can use that as a variable and to complete the MATLAB, which is basically you print out the statement using these as variables, right? Numbers, and that a day keeps the doctor away. So the rest of them, you know about the F strings, like print F strings. The F strings basically it's a formatted string with like variable. You can use a you know, curly brackets, you know, like for example, eating something a day keeps the doctor away. Okay, so something like that. Now you have to fill out this, like let's say how do you call it? I call it variable, right? Number, for lack of other, or item. Okay. And of course I can do this number and item. I can make it I don't know, tuple, right? So I can convert that to a tuple. Okay, so I don't need to print out this. I don't know if that works. Let's try it. Apples and 5. So you're eating apples 5 a day. Okay, so basically you want to swap them, right? So first of all, item is first and number is second, right? And then run again. Apple 5 apples a day. Does it make sense? So you basically use those variables as some placeholders in your string, right? Because all they change it is just these two variables, and you get these two variables from your input. Clear? And you can use this string to print them out. Now, of course, you have to use a while loop because, right? You have this special command, remember? Item not equal to quit, right? So if it's not quit, then you're gonna keep doing this, right? Now, of course, you have to do this once outside the loop, just to get you started, right? So you put into a loop until people hit quit, then you really quit. Okay, so use a while loop for the game, and internally, you don't need any loop. Let's say Apple 5. So, okay, Apple 5. There is some hiccup here because the initial one is discarded, you're not using it, right? Maybe what you can do is put them down below, okay? So that it will do that every time, because you already did that once here, right? So initially you already, let me just do quit password import your not enough value to unpack. Okay. Yeah, because so you have to handle that, right? You have to handle that. So maybe I should just using a list, right? That's better because list has a variable length. Because otherwise, if you only keep one, it give you an error, right? You're not expecting two numbers. Maybe you could say L1 list, list one, right? Or input list, okay? Input list is that. And then you want to change this to input list of 0, right? That's the thing. And this is the input list of 1. And what is this? Input list of 0, right? And then you just keep going like this, input list. Okay, so let's try it. Oh, here. So Apple 5. And then if I do quit, it will quit, right? So this time it didn't complain. Why? Because it's list element has a different length, and it always have a 0, at least one entry. But if you have more, then you can just print it out, right? Because I'm looking at the first entry. If it's quit command, I'm going to quit. I'm not going to do this anymore. Does it make sense? So that's the whole thing required for the lab 4.17. This is the one where, of course, you need to put your comment here. Okay? That makes sense?
Yes.
All right. So let me. So yeah, that's the end. I'm gonna stop the recording.